All right. Now the next thing we are going to focus on is ingestion. Okay, and we will be building the ingestion pipeline. All right. In ingestion pipeline, we're going to start with clinical trials client.py. Okay, if you actually open this file, I have actually written some documentation already for you. Okay, by the time you get this file in the GitHub repo, this will be, very well documented, all of that. But as of now, I cannot focus, I cannot write documentation for each and every step because I have to explain at the same time write code, right? But when you will get this file, it will be documented. Cool. What is the purpose of this file? Okay, this is the first file that talks to the outside world, which is outside databases. It connects to my clinical trials GOV and stores every registered medical research study, and it also downloads those study records and returns them as Python dictionaries. Okay, what it does step by step I have already included here. It basically creates a connection to the API. Then it is going to search for the relevant research studies as per the condition, as per who is the sponsor, etc. It is going to handle pagination requests, and the API is going to return around 100 studies per page. It is also going to handle failures in case if the API is slow, okay, or let's say the connection drops, then we're going to perform automatic retry, and it returns raw study data exactly as the API gave it to us, okay, and we never modify the data here, okay. That is document.parsers job. We'll see that, okay. All right, here I have just also defined the design decision we are going to make. The thing is, whatever codes we're going to write, we're going to follow software engineering principles, okay. We are going to write codes in such a way that tomorrow, in case there are multiple users who are accessing this particular platform, we're going to keep those things in mind. We're going to use concurrency. We're going to keep concurrency, all of those things in mind. Okay, rate limiting, retrying, fallback, all of them. Yeah. Cool. All right. Now, do you have to run this file? No, you don't run this file. Okay, this file is just a client. Okay, it provides a class that other files are going to use. Okay, and we're going to run the entire pipeline, run ingestion.py. There, this file will be automatically. It will take this file and it will run. Okay, you can see here we are using what? We are using async as what I said, async and await. Okay. All right. So let us go back writing code to write the code. Okay, so first and foremost I'm going to import async IO. Okay, so I'll just write here import async IO. And what is async IO? It is basically Python's inbuilt library. Okay, and this is typically for writing the async code. Okay, and async await, that lets your program do other things while waiting for the API to respond, right? Because it is working asynchronously, and instead of just sitting there and doing nothing, even when you're hitting the API, when you're doing the request, getting the response, and between that also you can run the processes. Okay, you can think of this like let's say you are placing a food order, okay, at the same time doing other things while waiting for your order to come. Okay, after async IO, I'm going to import requests. Okay, requests is basically the most popular Python library that is typically for making the HTTP calls, right? HTTP, as you know, is a protocol, hypertext transfer protocol, which is used to talk to web APIs, and this is the same protocol that your browser uses when you visit the website, right? And we typically use requests instead of HTTPX, right? Because clinicaltrials.gov API, it blocks HTTPX, okay, at the TLS fingerprint level, but it accepts the requests. Okay, all right. Then I'm just going to say from typing import any. Okay, and from typing import any. Okay, any is what? Any is basically the type hint, right? Type hinting, basically that suggests that this particular variable can be of that particular Python type, etc. We typically use it for API responses because the structure varies, right? Sometimes it is a dictionary, sometimes it is a list, depending on the endpoint, right? Then I'm going to say from tenacity, I want you to import retry, then stop after attempt, and weight exponential, okay, and retry if exception type. Okay, looks good. All right. So Tenacity is basically a Python library that is specifically built for retry logic. Okay, so instead of writing our own while loop with try, except, and sleep commands, Tenacity is going to give us clean decorators, okay, that are going to handle the output. Okay, when it comes to retry is the main decorator that is going to enable the retrying process. Stop after attempt, let's say I'm going to say stop after attempt 3, so give after the 3, give up after the 3 failed attempts, okay, is what it means. Weight exponential, let's say it's like wait for 1 second after the first trial, 2 seconds after the second trial, 4 seconds after the third trial, so it exponentially waits. Okay, and this is called as exponential backoff. Okay, this process is called as what? It's called as exponential backoff. Many a times you will read about this thing. Okay, so we basically are giving server more time to recover before each retry attempt. Okay, and retry of exception type, this is the only retry on specific error types. Okay, we only retry on network errors, okay, and not on 404 and 403 kind of errors, which are typically our faults sometimes. Yeah. All right, so I'll just say from config.settings I want to import setup logging. Okay, if you can recall, right, in config.settings we have the setup logging that we're going to import here. We're going to basically this is our centralized logging function, if you can recall. Yeah, and every file in our pipeline is basically going to use this. Okay, and then I'm just going to say logger equals to setup logging, and then I'm just going to put in name. Okay, so this is going to create the logger for each specific file. Okay, name is basically a Python built-in, right, that equals to it's like the current module path, right? Cool. Let us just define the constants that we have. Constants include first and foremost the base URL. Okay, and base URL I'm going to just say settings.clinical trials base URL. This is the base URL that we have defined in settings. Okay, yeah, I think that is fine. Yeah, why is it showing this? Okay, fair, no issues, I'll see this later. After this, I'm just going to put in the page size. Okay, page size is, let's say I'm going to say settings.clinical trials page size. You can just go back to these files and you can refer. We have already defined this in settings. Okay, then the request timeout part, I'm going to set it to 30. So I'm going to, like, how many seconds you want to wait for the API to respond. Max number of retries, I am going to set it to 3. I'm also going to set the headers. Okay, so let me just set the headers and then I'll explain you what are we doing here. Okay, I'll just say accept. Okay, I'll say application/JSON. Okay, basically tell the API that we want, the output in the or the response in the JSON format, right? And JSON is typically the text format that Python can easily convert to dictionaries, right? We know this, right? And without this header, okay, API might actually return you XML or HTML instead. We don't want that. We want the response in JSON. That is the reason we're defining this. Okay, and then I'll be defining user agent. Okay, I'll be just writing here Mozilla, okay, 5.0. In fact, let me just take it from the net itself, from the documentation itself, because I might lose out on some question mark or something, not question mark, any item here and there. Yeah. All right, so now let me discuss this. Okay, what we just wrote here. Okay, this is the base URL. Okay, this is the starting point for all the API calls. Okay, every endpoint we call is built for this particular base URL. Okay, So for example, how is going to be the output here? The output will be, let's say, base URL plus whatever studies, like, okay, we'll see that. Okay, page size is basically, we know this, how many studies, research studies we want per API call. Okay, let's say we want to set it to 100, right? So we're going to put it to 100, not 1000 or something like that, because we want to keep rate limiting in mind. Then request timeout to 30, which means how many seconds to wait for the API to respond. If the API does not respond in 30 seconds, we give up on that particular request. Okay, and without a timeout, our code could hang forever waiting. We don't want that, right? And 30 seconds, I think, is good. It's generous, right? Maximum number of retries are 3. Okay, which means first attempt plus 2, like first attempt plus 2 retries is going to be 3 total attempts. Yeah, before giving up, right? And this also handles the temporary network issues without crashing the pipeline. Yeah, and then you have the headers part. This is something that we've already discussed. User agent part that I've defined here. Now this tells my API what kind of client is making the request. Now typically I'm working on a MacBook. Yeah. Now when it comes to clinicaltrials.gov, it has bot protection that blocks requests without a realistic user agent header. Okay, and this header makes a request look like it came from a real Mac that is running on the Chrome, which bot protection accepts. Okay, so we confirm this exact. Yeah. So if you want, you can just put it on ChatGPT Gemini and just check like what is the alternative in case if you're running from Windows. Okay, cool. All right, so now let us go and define the client class. Okay, so I'll just say here defining the client class. Okay, and what is the class? My class is nothing but it's a blueprint for creating objects, right? So what I'm going to do here is I'm going to create class clinical trials client. Okay, and this clinical trials client class that we're creating, it's basically a blueprint for object that knows how to talk to the clinical trials GOV API. Okay, and we're going to design it as an async context manager, which means you can use it with the async with keyword. Okay, I'll show you now. So we're going to use what? We're going to use the async with pattern here. Okay, async with pattern. Okay, this also guarantees that the HTTP session is properly opened before the use and properly closed after the use as well, even if the error occurs in the middle. Okay, so as I said, we are keeping a lot of things in mind, a lot of engineering things in mind before we actually discuss or we actually build something from scratch. Okay, in this case. Yeah. All right, so now I'll just put in here, I'll say this client handles everything needed, okay, to talk to the API, okay, which is opening and closing the HTTP session, opening and closing the HTTP session, handling the pagination part, then retrying automatically, okay, especially when the network fails. Okay, yeah, and we're going to use the async with operation here. Okay, so let us start with, okay, and here I'll just say I'll take the session, session, I'll just say requests.session, okay, none equals to none. This looks fine. Okay, looks fine. Okay, so now here this should be underscore session. Okay, now the underscore session that you see here is the HTTP connection, okay, to the clinicaltrials.gov API. Okay, we start it as none, okay, and it gets created in something called as aenter. Okay, you're going to now so we are going to use a session object, okay, which means that we reuse the same TCP connection. Okay, so we're going to use the same session object, which means we are going to use the same TCP connection for multiple requests. faster than opening a new connection for every simple API call, right? And the underscore session that you see here is a Python convention, okay? Meaning that this is internal. You cannot access it from outside, as simple as that, okay? All right, then I'll just say, I'll create a function enter. I hope that, yeah, absolutely. Okay, and what does it return? It returns the clinical trial client. Okay, let me write it this way. I think this is a far better way of building the code. In fact, what code you're seeing right now is very high quality. Okay, so this function basically is, or method, I should say method, not function. This is called automatically when we enter async with block. When we enter async with block, okay, it creates the HTTP connection, or rather I should say session, okay, and sets the shared headers, okay. Now the clinical trials client, if you see here, this means that this particular method is going to return the client object itself, the client object that we created here, okay. So we're going to assign it to it. So we're going to assign it with async with clinical trials, okay, async with clinical trials as client, okay. So now I'm just going to put in here, I'm just going to say self dot session, okay. I'm going to say requests dot session, okay. This is fine, okay. And now as I said, this is going to do what? This is going to create a new requests session. So a session keeps a TCP connection open between the requests, okay, and this is more efficient than creating a new connection for every single API call we make, okay. Then I'll just say self.session.headers dot update, and I'll just say headers, okay. So we're going to apply our custom headers to every request this particular session makes, okay. This means that we never forget to send the user agent header, the user agent header, okay. It is set once here automatically. It is going to be applied everywhere, every single time, okay. Then I'm just going to say logger.info, okay. I'm going to say clinical trials client open, fantastic, okay. And I'm just going to say return what? Return the client object, okay. Now let me just a minute. What is this? Okay. Now I'm going to create next function called exit, okay. So I'm just going to write async exit, sorry, okay. And exe val also we need, right? Exe val we need, exe tb also, yeah, looks good. All right, okay. Now basically this method is called automatically when we exit the async with block, okay. This method is called automatically when we exit the async with block, okay. And this closes the HTTP connection, okay, or HTTP session. I don't know why I'm writing connection. HTTP session, and it releases the connection, okay. And this runs even if the error occurred inside the async with block, and that is the whole point of context manager. So you're going to get guaranteed cleanup. The three parameters that you see here, exe type, exe val, and exe tb, okay, they contain the information about any exception that has occurred. So we do not use them here, we just close the session regardless, okay. All right, so I'll just say if self.session, okay, and I'll say here only close if the session was actually created. Looks good. and then I'll just close it. I'll just say self.session.close. Okay, so this means close the HTTP connection and release the TCP connection. Okay, without this, connections would leak, okay, staying open indefinitely, and it is going to waste the server resources. We don't want that, right? All right, now I'm just going to say logger.info, and I'm going to say clinical trials client closed. These things are very important, guys, because we are working concurrently, right? So we have to engineer it in a bit different way. Okay. All right. Okay. So now, next part, what we're going to do is we're going to create a function next. Okay. Wherein we're going to define, or or we're going to create the core method, and that is typically for search studies. In the same file we're going to do that. Okay, but let's build that in the next video.